and welcome to
the Ultimate Cotton Challenge Supply Chain Edition.
Yes, because in London we presented the first edition on Open Container Initiative, and here we are back with a new quiz, this time to present the supply chain. So we hope that you will have the chance to test your knowledge around this area. It's going to be lots of fun, and we hope that will. We hope, and then we hope that you will also learn a few things thanks to our demos. So without further ado, Aurélie.
So I'm Aurélie Vache. I'm a developer advocate at OVHcloud. I'm specialized in cloud-native, Kubernetes, infrastructure as code, and developer experience. And you?
And I'm Sherine. I work at Red Hat. I'm working on the OpenShift distribution of Kubernetes. I'm an active community member in Marseille, France, where I live. And are you guys ready?
Yeah.
This is our QR code. If you scan it, you're going to go to our Slido quiz, right? It's going to be a white page with a blue banner. So at the moment, just scan the QR code. While we do that, I'm going to tell you a little bit of the story of this talk. So Aurélie and I built an image. It's a Golang app called the Gophers API. We built it through a CI, just like everybody else. As you can see, we have a lot of bad things that could happen, and we want to take this image all the way to production in a safe way. So, are you ready for question number 1? This is where we're going to ask you about your alias. So while you enter that, I'm going to keep telling you about our story. Aurélie here is the representative of the dev team. Yeah. And I'm going to be the bad guy, the security guy. I'm going to try to be a bit tough about security.
Oh, the journey, yeah. More and more and more and more. The third father. Oh, score.
All right.
Anonymous. Perfect. Just
who's the tall guy?
Awesome. So, right. Is it okay for you? Yeah?
Let's go.
Almost.
Okay, first question is going to be about the most basic thing. Which base image are we going to use? Right? So when you're choosing base images from a public registry, like Docker Hub, for example, are the images that you find there always signed and secure? Easy.
It's an easy question, yeah.
This is just for you to get familiar with the app or with the website.
So, what do you think about that? Yeah.
All right.
Easy. They're smart, yeah.
All right. So,
nickname. Yeah.
Okay, so as you can imagine, you can't trust any image you find out there, right? What you should look for is signatures. And when I say signatures, is don't just see a sign that says there's a signature. Look for the certificate authority that's behind it and certify that you can trust that. And also look for the security scan. This is very important. So on Docker Hub, for example, you've got a few icons that can help you do that. On Quay.io, you can find the small shield that says if an image is signed. And also there's a security scan by default by Claire. On Harbor, you can find a green check mark whenever there's a signature, and a cross, a red cross, when it's not. And also you can find the SBOM details and the vulnerability scan results. So we've established that signing is important to get the integrity of the image that we're going to deploy, right?
Okay, yeah.
So question number 2.
Question number 2. Yes, yeah. What tools allow you to sign an image? Pick 2 answers. ORAS, cosign, notation, or Trivy. Tick-tack. Pick 2 answers, yeah. 5 seconds. We will see what will be the answers. Oh, interesting. Yeah. And the good is cosign and notation. Congratulations to Mert, Saxophony, and Moose. So, yes, signing an image is important. it is a proof that the image that runs on a cluster is indeed the image that you built. And you can sign with cosine and notation. And as the Docker content trust is now retiring, Docker recommends to use cosine and notation tools. So we will do a little demo? Yeah? Okay.
First demo.
So first, we will sign an OCI artifact, push it also on the private registry with the cosine command. So we are using the new button format tag flag because cosine had a big release and now to follow the OCI distribution spec 1.1, we need to use this new flag, and we will use it. So we need to log in with GitHub.
So it's going to use my GitHub account to
with
create a
Sherine
certificate.
identity. So let's go back. And now our image will be signed. And we can also do the same thing with notation. Another tool. First, we have to create a key and a certificate with notation cert command. And then we can use notation sign command, and we have to use another flag, allow reference API to follow the distribution spec 1.1. So, okay, let's do it. And the signature have been created. Okay, it's cool. Let's check it. Yeah. So we are on a manager arbor at OVHcloud, and now let's go back to this. I'm clicking on my image, and as you can see, the notation image is here, and we generated the old format of cosine, and as you can see, there is a subject.accessory.
Yes.
What is it, Sherine?
So that's the signature which we created
Yeah?
with cosine. But it's not yet fully recognized by Harbor. There's an open issue for this. And so hopefully
We open it, yeah.
soon, Harbor
Yeah.
will be updated so that you can see the cosine icon there.
Yeah, and we have tips. It is also possible to sign an image with Postman. So we have first to define a SigStore program file with some record and a certificate field, and we can use Postman push command with the sign by SigStore flag parameter. And that's it for me.
All right.
Up.
So now we have a signed image. We know that what we're going to deploy is signed and has an integrity. But what about the contents of the image, right? So we need to know what's inside this image, and that's usually through an SBOM, right? So my question to you is the following. When we're running two different SBOM tools against the same image, do we get the same SBOM content? Yes, or unfortunately, no.
I don't know.
I'm not guiding you, right?
Trauma. It's a trauma, yeah. Oh,
Yes.
you're right.
You're right. The right answer is no. So just, Mert, you're doing great, man. So SBOM's just a small parenthesis. It's an inventory of all the things that compose the image from the top down, right? And that's what's going to help us understand what's inside and if it's safe. There are two possible formats, SPDX and CycloneDX in the open source world. Unfortunately, the common misconception is to think that just because you generated the SBOM, it contains everything. Okay, so the tools that you use will use several techniques to create the SBOM. So they might go and look at the file system. They can look just at your go.mod or your pom.xml and just stay there. They can do binary analysis, usually not open source, but, or they can piggyback on what you have in your CI system, right? So choose your BOM tool according what's inside your image, right? So let's see that in a demo. So first I'm going to use Trivy to generate an SPDX formatted file for the Gophers API. So I'm still using the same digest that Aurélie used for the signature earlier. Right, so this is going to pick up that there's an Alpine OS inside it and there's one language, Golang, expected. We can also use Docker Scout, Podman, or BOM to generate this. So now I'm going to look at the content of the SBOM. I use BOM for that. So it's another tool. So BOM document, outline, and then we see here that it picked up on the Gophers API Golang package with the dependencies, and on the Alpine, right, and its dependencies. Now, if I do the same with the BOM SBOM, so the SBOM generated by BOM itself, right, I can see that I don't get the same content. It picked up on the fact that there's an Alpine in there, right? That's it. It stays really up level, high level. So choose wisely. Then, now that I have an SBOM, it's important that I push it to the registry so that I can consume it right where I consume the image when I deploy to production. So I can do that using Auras attach. So I'm going to use a lot of flags there. But the important things to understand is that the SBOM that I'm going to attach here is not a signed SBOM, right? So that's also a risk to take. But with Auras, at least, it's when you push it like this, it's recognized by Harbor and it can show you the SBOM details when you show it. So let's go back to the presentation. Now we've got an SBOM. We know what's inside the image. We know the dependencies, right? But where did these dependencies come from? Did we get them from a shady website, or did we get them from an from a repository? Did we go stable? Did we go preview? What did we do?
Yeah. So, question number 4. What is SLSA provenance attestation? It is an inventory of all component and software dependencies, or a verifiable history of construction sources and dependencies, or the list of exploitable CVEs. So,
yes,
they're smart. Yeah.
They know their supply chain.
They win. Yeah, they know. They know. So, yeah, you're right. Mert is still on the top.
Go Mert.
So, SLSA, it's a set of incrementally adaptable guidelines for supply chain security. There are four levels of compliance. To be compliant for the level 1, you have to create a provenance attestation. It's mandatory. A provenance attestation is a document that contains metadata about where, when, and how the artifact was built. It's generally generated in CI with several tools. And to be compliant with the level 2, you have to sign the provenance attestation and distribute it in an in-toto envelope. And you will see in demo. Oh, let's go. So, first, we will generate the SLSA provenance attestation. We will attach it also and push it on our OVHcloud private managed registry. So, we can use the docker bulix command, and with the provenance mode max flag, we ask Docker to generate a huge file, a huge provenance attestation with a lot of information, a lot. So we can display it. Let's do it with docker scout attest get comment. So let's see what is the content of the file. Okay, we pull it, yes. So first, okay, it's an in-toto file with a provenance SLSA attestation, and we have some information. It is our Gopher API image with the good and the digest. And I know something, okay, the image I will build with Docker mobile, and I know the image Alpine, Golang, okay, and we have all the build step. So it's a use file. Oh, use file, okay. But I have a tip. We can directly extract the Docker file from this file. And we can do it with a little GQ comment. Little.
Yeah.
That's size, yeah.
Right.
Okay, so I'm the dev. So, okay, so the image I will build with a Golang 1.20. Cool, no?
Yeah,
no?
Okay, a little bit old, but okay.
Old? Oh, come on.
All right. So, okay, fine. But let's now go into the beefy stuff, vulnerabilities, right? So, we've got everything's fine. Now we have to deal with vulnerabilities first. So, this is my question to you. If my image contains vulnerabilities, is it still safe to use it in production? No, it's too dangerous. You have to fix all the CVEs, otherwise you don't go to production. Or only if they are not exploitable, or yes, all CVEs are useless anyway. All right.
Oh,
I'm not guiding you. No, no.
Ooh.
Yeah. Okay, so just before we go into that, just 1 sec. So yeah, I mean, our first go-to thing is to say, okay, we have an upgrade possible for the library, let's do it, but that's not so easy all the time. Like you could break APIs when you want to fix a CVE, and sometimes it takes a lot of time. So this is especially annoying when your code doesn't even call the vulnerability in question. So we need to have a way, and that's Vex. So Vex is the way so that we can say if these vulnerabilities are exploitable in the context of your application. So that's what Vex is doing. It allows you to say, this is my vulnerability, and this vulnerability is under investigation, it's not affected, it's fixed, what is it, right? So we've got 2 formats possible, CSAF and CycloneDX, and the Linux Foundation created OpenVex a few years ago, right? So I wanted to say something, but I forgot, but that will come probably with my demo. Oh yeah, I remember. So the reason why we don't put the Vex information in the SBOM is because the Vex is something that you need to update all the time. Vulnerabilities get found all the time. So even though your SBOM is going to be generated with your build, you have to create the Vex all the time and update it, right? So my demo is going to use Trivy again, in order to this time get a list of the vulnerabilities for our image, the Gopher's API image. Okay, so we're gonna just grab the stuff that we really need. Okay, I'm gonna scroll up. Oh my God, there's a lot of vulnerabilities in there. Sorry. Okay. Okay, so
My bad.
nah, we're gonna fix it. So if I take this one, first one, right? High severity, blah, blah, blah. Okay, but it says here, okay, if I'm using Golang 119 and below, I have the vulnerability.
Cool.
We're at 120, so we're not vulnerable. So how do we say that? we have to create the VEX file. But instead of like creating the VEX file and entering everything by hand, you can use a few tools like go-vuln-check, for example, creates these types of things around the dependencies of Golang. So let's do that. We'll create a JSON file, and with another JQ, I'm gonna look at what go-vuln-check has to say about this particular CVE. And as you can see, it does say that I'm not affected by this. Right, so that's great. So now that we have the VEX file, it's important that we also put it up on the registry so that Kubernetes later can go and grab it when needed. So this time I'm not gonna use ORAS, I'm gonna use cosign attest. And that's gonna take the predicate, so the VEX file that we created, it's gonna sign it and put it in an in-toto attestation and push it to the registry. Right, so I'm gonna, again, log in so that it gets a certificate for signing the image, the attestation, and we're done. The funny thing is, now that you have a VEX, you can point 3v to it. So you can even point 3v to the VEX file that's on the registry, right? So this way you have what 3v found as vulnerabilities, and this information can get enriched with whatever is in your VEX file, right? Okay, so let's recap. We've got a signed image.
Yeah.
We've got an SBOM. We've got the provenance. We've got a VEX. I think we're ready. But now,
almost,
we don't want to do this check manually every single time we deploy, right?
Yeah.
So what do?
We have a solution. So the last, go fast. So how can we check signature and attestation on a Kubernetes cluster? Pick two answers. With GitOps, with Kivano, with Kiali, or with Hopa plus Gatekeeper. What do you think? Go fast. I like it. Yeah.
Okay.
So, drum roll. Yeah, it's Kivano and Hopa plus Gatekeeper. So, congratulations, Saxophony, Mert, and Ezebonica. Please take a pic of your phone and go.
You can pick your
here,
goodies
after the presentation. Yeah. So, Kivano is a cloud-native policy engine, and you don't have to learn a new language, so it's cool. And you can you can create 5 types of rules: validate, mutate, generate, clean up, and verify images. This final rule allows you to verify everything for an image: tag, digest, signature, the attestation, SBOM, SLSA, and if the image is in a authenticated registry. Okay, so let's do it in our last demo. So let's create an image validation policy. It's the new CRD with Kivano 1.15. So, okay, so let's see our policy. So it's a check image policy, and we will check if the image Gophers API is signed with cosign and with the identity of Sherine. So, okay, so let's apply this policy in our OVHcloud managed Kubernetes cluster. Okay, so it's okay. It's created. Let's check it. Okay, so the policy is ready since 5 seconds. And now we will test to create a new pod with a signed image so with the digest of our sign image. Okay, so let's create it in our Kubernetes cluster with the kubectl apply command. Okay, it's created. Let's see if really on the cluster. Okay, so the sign gopher pod have one container ready and is running. Okay, so it's cool. So it's okay. And now let's test if we can create a pod in the cluster with an unsigned image. So with another digest. Okay, so let's apply it in the cluster. Oh, no, I can't. Kimono not allows me to create this new pod because the image signature verification is failed. And yes, as we can see, the pod has not been created. Okay, it's cool.
Nice. All right. So we hope that you learned a few things with us. This is a space that is in constant change, right? And
every day.
There's a lot of other tools that unfortunately we couldn't demo to you today. But what are the tools, for example, that we used in the demo? Right?
We saw cosine.
What else?
And
Trivi.
Horace.
yeah.
What else?
Notation. Yeah, right.
Yes. All right.
And Kiverno.
Kiverno, exactly. So this is a good takeaway probably for you guys. It's the list of tools that we used with a little superpower for each of them so that you can remember them a bit easily. There are a lot that, as I said, we could not really demo today for lack of time. Maybe next time, next edition maybe.
We won't, but we can't.
Yes. So thank you so much everybody for your attendance and for playing this game with us.
Thank you.
Do you have any questions? Maybe we've got 2 more minutes.
2 minutes. Yeah. Huh? No. Yeah, of course. So we have maybe 1 minute for a question. If it's late.
I can hear the question. What do you find most annoying about SBOMs?
What I find most annoying about SBOMs?
It's for you. Oh, it's for
Well,
you.
there's a lot of formats that exist is one, basically. And then they're not complete. There's missing data inside them.
Yeah.
And basically, it could give the customer a bad idea because they could say, okay, you've put the SBOM on the registry, so I'm going to go and look and say, you have to fix these vulnerabilities because you're using these packages. But like that's not really what's happening here. We have to use the VEX with it. So it's incomplete.